Hi everyone. So in this video, I'm going to talk about the difference of square, and I'm going to use one of the math counts problem for this. Okay. But before we get into this problem, this is a question that was given in the spring run on number 26, I believe, and you may just try to multiply these and multiply these, find their difference, and you can just go from there. But that's all okay if you have nothing else. But instead, I'm going to use actually the difference of square. But before we use the difference of square, I'm going to actually kind of show you how that looks like. Okay, so let's say we have x minus 1. Okay, and then if I'm going to multiply this by x plus 1, okay, you may multiply every term in the first parenthesis by every term in the second parenthesis. If you multiply like x by x, you do get x to the second power times x. And then if you multiply x by 1, so you get 1x. And that you multiply -1 by x, which is going to be minus x. And if I multiply these, so you will get -1. But these two guys, middle two guys, x and minus x, will add up to 0. So which is why this is actually going to be x squared minus 1. But I like to write this one as 1 squared. Just keep it in mind. Okay. So the x minus 1 times x plus 1 can be written this way. That is something. Let's try something else. Let's say I have a minus 4 times a plus 4. So if I multiply a by 8, so I do get a squared. Multiply a by 4, which is going to be 4a. And minus 4 times a will be minus 4a. And then -4 times positive 4 is going to be minus 16. You see, these guys is going to be still add up to 0. So you do get a squared and minus 16, which can be written as a squared minus the 16 can be written as 4 squared. So the reason I'm just kind of showing this because we want to really see that relation. So in this case, we have the square of x and minus square of 1. And that was the same as x minus 1 times x plus 1. And we have the square of a minus square of 4. That is actually a minus 4 and a plus 4. So this is actually really nice relation that we need to remember, and that's going to be called difference of square. So if you do have, let's say, x minus y, which is any two numbers, times x plus y, I can multiply x by x, and I do get x squared. Like if I kind of use the same idea, so I should expect a similar result, which means I expect this product to be x squared minus y squared. Let's see. X times x will be x squared, x times y will be xy, and then minus y times x will be minus xy, and then minus y and plus y, multiply those, you get minus y squared. As you see, these guys are doing nicely cancel each other, so that is just x squared minus y squared. So the product of the x minus y and x plus y is actually equal to x squared minus y squared. And this is actually something I'm gonna ask you guys to remember. Okay, x squared minus y squared is x minus y times x plus y. Again, this is called the difference of square because we have a square of two things, and then you just take their difference. So that's why this is called difference of square. Okay, so but if you look at our problem, we know it's not really obvious that we are going to use it. But as you see, this is 55, this is 53, and this is 59, this is 57. You look at these two numbers, like if I look at the middle number like 57, this is 2 lesser than 57, this is 2 larger than 57. So which is why I can actually write 55 as 57 minus 2 times this could be written as 57 plus 2. And similarly, if I look at these two guys, middle number is 55. So 53 can be written as 55 minus 2. And 57 will be 55 plus 2. And that is given x squared minus 1. So now I do see something minus something times something plus something, which is actually exactly this part of the equation that we just got. So that instead of these two, I can just say that would be 57 squared minus 2 to the second power. Because if you had this one, you could have You could write this way, but if you have this one, you can just write it backward. So that is the first part. And I have minus, and the same thing goes there. So 55 squared minus 2 squared, and that would be x squared minus 1. Okay. And now I do have a minus right here. Maybe it's better to expand those. So 57 squared minus 2 squared. If you expand this minus with that, so you will get 55 squared with minus in front. And this negative and this negative will become a plus 2 to the second power. That is x squared minus 1. So, you know, this is going to be add up to this, okay, which is going to be 0. And I have 57 squared minus 55 squared, which is also a difference of squared. So you can write 57 minus 55, okay, times 57 plus 55. Okay, understand? That would be 55. That is x squared minus 1. So the difference of these two is 2. And if you add 50, 50, which is 100, so 5 and 7, 12, which is 112. And that would be x squared minus 1. If you multiply, you got 224. And then if you add 1 to both sides, you got 225, which is x squared. And if you take the square root, so you should expect to get x is 15 or negative 15. But we can say what positive values. So you see, they are looking for the positive number. So which is why we just need to go with positive 15, okay, in this case. So some of you may ask, or do we really need to use difference of square? Because if you just multiply those numbers and find the difference, it looks like a bit easier than this, especially if you see the difference of square the first time. That might be correct, but as you will see later on, maybe in some exercise or in some like test, whatever, the difference of square will be a lot useful in most cases, even though in this case, we don't really need to use it, but I just like to use the difference of square, so you can at least see another way of doing this problem, okay? So I hope that makes sense, and I'll see you next video.